Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I am your instructor, Engineer Hassan Khan, and this is Engineering Hydrology. Today we will discuss the lecture number 7 of this course. The lecture consists of the following contents. We will discuss about average precipitation over a basin, and then we will also discuss and explain calculation of average precipitation by arithmetic mean method and by Thiessen Polygon method. Okay, so estimation of average precipitation over a basin. Whenever there is a precipitation, or you can say rainfall over an area, it is always not uniform over the whole area, but in some area the precipitation is more and in some area it is less, depending upon the different parameter of different aspect of the area as well as the weather. But for most of our hydrological analysis, we need an average value of precipitation. So therefore, we will convert the different precipitation values to a uniform, to an average, to a mean value. As you can see, to find out runoff from a catchment and most of other hydrologic analysis, it is important to know the average precipitation over a certain part of catchment or for the whole of the catchment area. Now, to find out average precipitation of watershed, records of precipitation from different rain gauge station is used. But there are many factors which affect the reliability of average precipitation of watershed, determined by using the data from individual stations in the watershed. The factors are like the total number of rain gauges and their distribution in the catchment. In your catchment area, in your basin, how much are the total number of rain gauges and how they are distributed in this area? Are they uniformly distributed or non-uniformly? As you clearly know that larger the number of rain gauges, the more reliable will be the calculated average precipitation. It also depends upon the size and the shape of the catchment area. Larger the size of the catchment area, less reliable will be the average precipitation. The precipitation, and also depends upon the shape of the catchment. Distribution of rainfall over the area and topography of the area. And the last one is the method used for calculating average precipitation. So these are all the factors which are responsible for calculation of average precipitation. Now, there are three methods commonly used for calculating average precipitation over an area. Accuracy of estimated average precipitation will depend upon the choice of an appropriate method. The methods are: number 1 is simple arithmetic mean method, number 2 is Thiessen Polygon method, and number 3 is Untitled method. In today's lecture, we will discuss the first two methods, that are arithmetic mean method and Thiessen Polygon method. The third method of Untitled will be discussed in the coming lectures, inshallah. So let's come to the first method, arithmetic mean method. In this method, the average precipitation over an area is the arithmetic average of the gauge precipitation values. We take data for only those stations which are within the boundary. And this is the simplest method, but it is applicable only for flat area and not for hilly areas. This method is used when basin area is flat. All stations are uniformly distributed within practical limits over the area, and the rainfall is also nearly uniformly distributed over the area. If these three factors are satisfied, basin area is flat, all stations are uniformly distributed, and the rainfall is also uniformly distributed over the area, then we can use the simple arithmetic mean method. Otherwise, if basin area is not flat, the hilly area, the topography is hilly, or the stations are not uniformly distributed, the stations are not covering the same area, or the rainfall is not very much uniform, then we will use the other two methods that are Thiessen polygon and the isophytal method. But if these conditions satisfied, normally these conditions satisfied in the plain areas, not in the hilly or mountainous regions, then we can use the simple arithmetic mean method. Okay. So according to this method, this is a very simple formula you use commonly for mean. Mean, how you can take the mean? Just sum of the quantities divided by the total number of the quantities. So P average is equal to 1 divided by n multiplied by summation of Pi, where I is starting from 1 to the n. Or if you expand this summation, then you can find the P average is 1 divided by n multiplied by P1 plus P2 plus P3 plus so on up to Pn. So here 1, 2, 3 represents the station number. P1 mean the precipitation at station 1. P2 mean the precipitation at station 2. P3 mean the precipitation at station 3, and so on. And the last one, Pn mean precipitation at the nth station, where Pi is precipitation at station I, and there are n number of gauges installed in the catchment area from where the data has been collected. So n is the number of gauges. Here is a very simple example on the first arithmetic mean method, but in the example it is not mentioned that you should solve this by the arithmetic mean method. So how to decide? Let's see the example. We have 6 rain gauges installed in a relatively flat area, and storm precipitation from these gauges was recorded as 3.7, 4.9, 6.8, 11.4, 7.6 and 12.7 centimeter respectively from gauges 1, 2, 3, 4, 5 and 6. Find average precipitation over the catchment. Now again see this example. So here we have 6 rain gauges. How much gauges? 6 gauges, represented by number 1, 2, 3, 4, 5 and 6. Okay, the region or the area is relatively flat. If the area is relatively flat, so this flat area points out, this statement points out that we can use the simplest method, that is arithmetic mean method. And storm precipitation from these gauges are also given in the centimeter unit. So for the first gauge, the storm precipitation is 3.7. For the second, it is 4.9. For the third gauge, it is 6.8. For the fourth, it's 11.5. Fifth one, 7.6. And for seventh, 12.7 centimeter respectively. So in the solution, we will just put the formula of the arithmetic mean method, and then we will expand the formula up to n6, mean for 6 gauges. So if we expand this for 6 gauges, we will get the formula like this. P average will be equal to how much? P equal to P2 plus P3 plus P4 plus so on, and the last will be P6. So how much are the total? 6. So bracket these values and divided by 6. So P average is how to calculate it. So 1 by 6 into all the values, putting all the P values, P1, P2, P6. So summing up the values divided by 6, we will get the 7.85 centimeter. Okay, the second method of calculating average precipitation over a basin is the Thiessen Polygon method. The fundamental principle followed in this method consists of weighing the values at each station by a suitable proportion of the basin area. In this method, a special weighing factor is considered. The following steps are used to determine average precipitation by Thiessen Polygon method. You can see here. First of all, draw the given area according to certain scale and locate all the stations' position on this map. Like this is the catchment area according to some scale, and then we have to locate all the stations. Let's suppose we have 6 stations in this area, and we have located all these 6 stations by these points. Second step is join all these stations by straight lines. In this way, we will get a series of a framework of non-intersecting triangles. Third step is draw perpendicular bisectors and get a suitable network of polygons, each polygon enclosing one station. Draw perpendicular bisector on all these dashed lines. So like this. In this way, as you can see, the red lines cover, each station is covered by a polygon like this. This is one polygon around this station. This is another polygon around this station. This is another polygon around this station. This is another polygon around this station. And also this is a polygon around this station. Here it's a polygon around this station. So what we will do next is precipitation over. Now in this method, it is assumed that the precipitation over this area, or the area of this polygon, is uniform throughout this area, and the value of the precipitation of this area is assumed to be the value of this point, the gauge value. So precipitation over the area enclosed by the polygon is assumed to be uniform. The last point is measure the area of each polygon. Now we will measure the area of each polygon. For measurement of this area, there are various methods used. If you have drawn all these maps in all this geometry in the AutoCAD, then you can calculate the area just by putting the area formula in the AutoCAD and selecting the polygon for which you are finding the area. You can easily calculate the area. If you have drawn this on a paper, or if you have a hard form map of this, and on the paper you have drawn these polygons, then for the paper, one is instrument use, the name is planimeter. You can use the planimeter to find out the area from a paper or from a hard map. The second method is, if you have trace paper, you can put tracing graph paper. You can put the tracing graph paper over the map, and you can calculate the number of blocks within each polygon, and by that way you can calculate the area according to scale. So when you find out the areas of all the polygon, the precipitation values of all the gauge station values are already known. So what then, and then how we will calculate the average? Then calculate the average precipitation for this whole catchment by using this formula. This is the formula of Thiessen polygon. P average will be equal to what? Summation of Pi into Ai. Summation of Pi into Ai, where I starting from 1 to n. N is the number of stations. Like in the previous example, how much were the stations? Total number of stations were 6. So it will start from 1 to 6. So divided by summation of Ai, where I starting from 1 to n. Okay, where what does it mean? It means that the summation of all the polygonal areas, polygon number 1, polygon number 2, polygon number 3, all sum up to Ai, will be divided by Ai. So in expanded form, if we expand this formula, we can write it like for n station like this: P1 into A1 plus P2 into A2 plus P3 into A3 plus so on up to n Pn into An, whole divided by capital A. What does it capital A represent? Here the P1 mean the precipitation at station 1. A1 mean the area, the polygonal area around the station 1. P2 mean precipitation at station enclosed by polygon of area A2, and so on. Pn is the precipitation at nth station enclosed by the polygon of area An. And the last, the A in the denominator represent the total area of the catchment. Now let's solve some example on this Thiessen polygon method. Example number 1. Here following is shown map of catchment having 6 rainfall recording stations. Find the average precipitation over the whole catchment. Now this is the whole catchment, as you can see by this dash line. This is a river flowing in this direction. Okay, and all these are the gauging stations. One of the precipitation gauge is in the Bisham, and the value of the precipitation is 33 millimeter. Shinkyari, Holia, Ogi, Turbela, and Dagger. 1, 2, 3, 4, 5, 6. These are all the 6 precipitation gauges. In the map, in this example, we have already given the already prepared map. Mean the area is drawn into the scale, the stations are marked, the stations are connected by the straight lines, and then the bisector of all lines, and we have get this completed map in which each station is enclosed by a polygon like this. So the values of we have to calculate the area of these polygons individually and then sum up all the areas to calculate the total area of the catchment. And the values of the gauges are already given. So the precipitation and polygon area are given below. So let's suppose we have calculated the areas, or we are given the areas in this example. So the station of Dagger has a precipitation value of 48 millimeter and the polygon area is 5068.76 square kilometer. In this map, if you look into detail, here the largest polygon is, I think, the Dagger one, and the smallest polygon is Shinkyari. So if you can look into the values of the polygon area, the largest value in 5000 is the Dagger value, and the smallest one is the Shinkyari, which is 1399. This is the smallest polygonal area and this is the largest polygon. So all the polygonal areas and the precipitation values are given here. So what we will do, the solution, we just calculate it by multiplying the precipitation values into the respective area. Like again, the calculation here are given in the tabular form. At Duggar station, we have the precipitation P values, how much, 48, and the area of the polygon around the Duggar station is how much, it is 5068.67 square kilometer. So what we will do, we will multiply the 48 millimeter into 5068.76 square kilometer. But remember, you cannot multiply a millimeter into a square kilometer. So what we will do, before multiplying, we will convert all these into consistent unit. So we will convert this millimeter into meter and this square kilometer into square meter. So to convert this value into meter, we will just remove the 1 m. And you know the value of 1 m, the milli value is 10 raised to power minus 3. So this is now in millimeter, it is 48, but if we write it in meter, it will be how much? It will be like this: 48 multiplied by 10 raised to power 48 multiply by 10 raised to the power minus 3 meter, minus 3 meter. So now this is in meter. So multiply this with this, but in square meter. So for converting this square kilometer into square meter, we will multiply this value by how much? By 10 raised to the power 6. So as you know, the value of kilo is 10 raised to power 3, but there is a square, so it will becomes 10 raised to the power 6. So now this is the value, actual value. Now if you multiply these both 48 into 10 raised to power minus 3 meter into 5068.76 into 10 raised to power 6 square meter, you will get 243.3 into 10 raised to the power 6 cubic meter. So in the same way, all these are multiplied. 33 is multiplied with this one, similarly there. So after multiplication of all these 6 stations, precipitation and polygonal areas, then finally we will sum up all these polygonal area. So this is the total catchment area, 16,941.60 square kilometer. And also we will add up all these values. Now as you know, if we will sum up all these values, this is actually the summation of pi into ai. So the summation of pi into ai is this one, and this is actually the value of this. Okay, similarly the total area, this one is the value which is here. So again, to make the unit, remember to make the unit consistent. So putting the values, summation of pi into ai 666.02 into 10 raised to the power 6, remember this value, cubic meter, okay, divided by 16,941.60 into the unit of this is square kilometer. Okay, now so the mean precipitation in this situation is like from the previous, we have just changed the square kilometer into the square meter, because this is in cubic meter, so this should be in square meter, not in square kilometer. So we will put here a 10 raised to the power 6 to convert a square kilometer into square meter. So this is already available. So now what we will do, we will divide only 666.02 divided by 16941.6. so we will get how much in 10 raised to the power 6 is cancelled with 10 raised to the power 6. Square meter is cancelled with this cube. Square meter complete is cancelled with this cube. 10 raised to the power 6 is cancelled out with 10 raised to the power 6. So what remains? 666.02 divided by 16941.60 on and only 1 meter. So if we divide this will give us 0.0393 meter. 0.0393 meter can be written like this one, 39.3 into 10 raised to the power minus 3, because this point is displaced 1, 2, 3 digit, so we will get minus 3 meter. So 10 raised to power 3 mean 1 divided by 1000, and 1 divided by 1000 mean milli. So in place of this 10 raised to the power 3 we can write down millimeter. So the answer of this is mean precipitation of this area is 39.3 millimeter. Next example, this is just the same example. The only difference is that here the data is given in the tabular form. Here the map is not given, just we know the data, and we will calculate the average precipitation from this data. From the data given in table below, which was obtained from Thiessen Polygon map of a catchment, find out the average precipitation of the catchment. In this table, if we look into number 1 is the serial number, or you can say the station number. So how much are the total stations? There are 6 stations, 1, 2, 3, 4, 5 and 6. And the gauge precipitation, but the gauge precipitation values in this example are given in the centimeter unit. In the previous it was given in the millimeter. Now here it is in the centimeter unit. And the third column is the area of Thiessen Polygon enclosing the station. Enclosing the station 1, how much is the area? Is 416 square kilometer. The station 2, around the station 2, the polygonal area is 260 square kilometer. So, and the precipitation values are here. So the only difference is that the data is given in the tabular form and the precipitation values are in the centimeter, not in the millimeter. So according to Thiessen Polygon method, P average is equal to P1 plus P2 plus so on Pn into An, summation of Pi into Ai divided by total A. So the calculation are shown in tabular form. So here the gauge precipitation values are in the column 1, which are represented by Pi, and these are in the centimeter: 10.2, 8.1, 12.7, 9.4, 15.2 and 7.6 centimeter. Area of Thiessen Polygon enclosing the station 1 is how much? Is 416. This is in column 2, and this is represented by AI. AI mean A2, A3, A4, A1, A6, A5 and so on. Pi mean P1, P2, precipitation 1. So what we will do, we will just multiply the first two columns, the column 1 and column 2. The column 3 is actually equal to the product of column 1 and column 2. So multiply this 10.2 centimeter into 416 square kilometer. Again, remember the unit conversion and consistency of unit is very important. Here it is centimeter, 10.2 centimeter. What does centimeter mean? Centi mean 10 raised to the power minus 2. So this is actually 10.2 into 10 raised to the power -2 meter, and multiply this value with 416 square kilometer, mean 10 raised to the power 6, mean 10 raised to the power 6 square meter. So if you multiply this, so this is 10 raised to the power 6 plus, and this is -2. So combining these, we will get 10 raised to the power 4, and just multiply 10.2 into 416. So you will get 4243.20 into 10 raised to the power 4 cubic meter. Remember, this 10 raised to the power 4 cubic meter is common from all these. So this is multiplied with this one, with this one, with this one, with all these, and finally with this also. Again, these are the summation of the column number second is this one, and the summation of the column number third is this one. This is actually the summation of pi into ai, and this is the summation of the area, which is represented by capital A, by this. So just put these values into the formula, you will get the answer like this. P average, again this, so the value of all this is how much? Is this one. So putting this value 27,890.20 into 10 raised to the power 4 cubic meter divided by this value 2561 square kilometer. So in the first step, this is the same. In the first step, what we have calculated, we have just put the value of square kilometer into square meter. So kilometer means 1000 meter, but remember this square is not only about this meter, but this is on this complete unit kilometer. So if we put the value of k 1000 and take square, so it becomes 10 raised to the power 6. So just conversion factor, this 10 raised to the power 6 is just a conversion factor for converting the square kilometer into square meter. Okay, all other things are the same. So just divide this value by this value. As you can see, 27,890.20 divided by 2561 multiply by 10 raised to the power 4 meter and 10 raised to the power 6. Remember, this is cancel out, this square meter is cancelled with this q, so we will remember with only 1 meter. Okay, now here is it's -6, it's -6, remember. So what will be the answer? The answer of this is 10.89, and this 10 raised to the power -6 and 10 raised to the power 4 becomes 10 raised to the power -2, and 10 raised to the power -2, as you know, is known as centi. So 10.89 centimeter. So this is the final answer of the example number 2. Now here again example number 3 on the Thiessen polygon method. Here it's again the same type of example just like the previous example, but here it's given for one thing. The one thing is that there are 10 observation stations, 7 being inside and 3 in neighborhood of a catchment. Thiessen polygons were drawn for a storm data from these observation stations, and the data given in table below was obtained. Find out the average precipitation of the catchment. So the only one thing in this example which is different from the previous one is that that here the total station are how much? 10, but 3 stations are in the neighborhood, not in the catchment. 3 stations are out of the catchment, 7 are inside the catchment. So in this example we are just clearing that if some stations are out of the boundary of the catchment, we will never ever use the values of those stations. So the data given here is only for the 7 station, 1 2 3 4 5 7, and the gauge precipitation values again in the centimeter in the area of Thiessen polygon around all these gauges in the square kilometer unit. So solution again the same formula expanded, but here we should expand this formula for how much station? For 7 station. We will write down P7 into A7 and expand this formula up to the 7. So this is the gauge precipitation value 5, and the area of the first polygon around the station 1. Again we will just multiply the column 2 and column 3, column 1 and column 2 to get the column 3, the volume, and we will get the PI into AI. The PI is this one, the AI is this one, so 5 into 100 is 500. But remember, this is centimeter and this is square kilometer, and already we have done the conversion. We will just multiply this value and write down 10 raised to the power 4 for the conversion, and the answer will be in the cubic meter. So all these values are multiplied, and in the third column we have got in these values. So sum of this value, sum of all these areas values, we will get the total area of the catchment, which is 1200 square kilometer. And summing up all these values, we will get the summation of PI into AI, which is 5157.50 square kilometer. So just put the values of summation of PI into AI and summation of AI. Putting these values, we will get this one, and the answer of this example is 4.3 centimeter. Okay, again this was all about the lecture number 7, and the recommended textbooks and reading references for my all lectures are given here, but I'm usually using the first one. Okay, thank you very much. Once again, I'm Engineer Hassan Khan, and if you have any question, issue or problem, you can contact me through my email address hassan.sebel@su.edu.pk. Thank you.